All right, this is the axial skeleton lecture that actually was the lecture we did in person in the lab during the week when we all came into the lab. So basically, I'm going to walk you through everything that I did in lab with the photographs so that you can review. So axial skeleton. We're going to start with the vertebra. The vertebra are the cervical region, thoracic region, lumbar region, and sacrum with the coccyx. There are 7 cervical vertebrae, and we number them C1 through C7. There are 12 thoracic vertebrae that we number T1 through T12. There are 5 lumbar that are numbered L1 through L5. There is 1 sacrum, but it has 5 sacral vertebrae. So there are 5 bones in the sacrum that are fused together. The coccyx is the one region that has a variable number of bones. We call it the coccygeal bones. It can have either 3, 4, or 5. If somebody has 3 bones, they are female. If they have 4 bones, they are either gender. It doesn't seem to matter much, and 4 is the most common. If somebody has 5 bones, they are male. Okay, this photograph is a drawing from your textbook. This is a typical vertebra with the typical landmarks. So the landmarks that you would have to be able to identify are the body, and the body is this whole thing, right? Each pedicle comes off of the body as basically a piece, and then the lamina is posterior. And in class, I did this drawing of the pedicle, and then I did lamina, the spinous process, lamina, pedicle, and I said that whole thing was the neural arch. So that is what the neural arch is, the pedicle to lamina and lamina pedicle. And that the neural arch with the body makes up the vertebral foramen. Now the word foramen means hole or opening. We see it in many places, not just bones, but you have to remember that the vertebral foramen is for the spinal cord. It's called vertebral because it's in the vertebra. A hole between vertebra would be intervertebral. So this one is just vertebral. The spinous processes extend from the junction of the pedicle and the lamina, and the spinous process extends posteriorly. So this is a photograph of a bone from the lab. This is one that I took, and I've marked those same exact landmarks on this vertebra, noting the fact that you cannot see the inferior articular process from this view, but you can see superior articular process, the transverse process, and the pedicles. Laterally view. So in the lateral view, I pointed out the body and how the pedicle works. I mostly took this view so that you could actually see the superior articular process, which I just highlighted in the red. It points superiorly. That's for a synovial planar joint with the bone above. Remember, each bone has 3 attachment points to the bone superior to it, the body, and each superior articular process, that's 3 points, and 3 points for the bone that is inferior to it, again, the body, with the 2 inferior articular processes, which I am now highlighting with the red. The other thing the lateral view gives us is a good view of the spinous process. This one is wedge-shaped because this is from the lumbar region. Each region has its own shape for the spinous process, but you can clearly see it in this lateral view. So the next thing we're really going to look at is regions. How do you know what region a vertebra is from? So if you're looking at the cervical vertebra, what we first see is the bifid spinous process. That means it has the fork in the tail. It's got 2 pieces, bi meaning 2. Another piece is this small oval body, which we remember means not just small over in comparison, but the fact that it's small in comparison to the rest of the bone. The body is only about 1/3 of the total mass of the bone. But the key element to the cervical region are these circles, these openings here in the transverse process. They are the transverse foramen. They are for the vertebral artery to go up into the brain for the brain stem. That is the key element to any cervical vertebra, is those transverse foramen. So keep those in mind. Cervical has two special bones. C1, the atlas. This is one of two bones that you'll have to be able to recognize exact number and a name. The rest of the cervical, like a C5, you just have to say it's cervical. You don't have to tell me which one it is. C1 is different. It has a name, the atlas. This is the first vertebra. You'll notice that it has no spinous process and no body. The body should be here between the two articular processes. But it doesn't have it. It does have this key transverse foramen though. You can just make it out there on the side, but we have no body for the atlas. Remember, atlas holds up the head. C2 is the axis. This is the other bone that you have to know both exact number and the name. We do have a spinous process. It's a little broken on this one. We have a body, but the key to the C2 is the dens. The dens without an E means tooth-like projection. It's also called the odontoid, from the same root word as dental or dentist. If we put these two together, we get the atlantoaxial joint. This is a synovial pivot joint, which you can view in the arthrology lecture. They basically fit together and they make this perfect pivot joint, which is why you can rotate your head. This is the no movement of the head. We have C1 to C2, the atlantoaxial joint. Thoracic. How do you know thoracic? We have a heart-shaped body. It's not a perfect heart, but it kind of comes up on each side and it comes down here. So I've made my drawing just a little bit more heart-shaped than actual, but it does have a more heart-shaped body. The transverse processes aim posteriorly, and we have facets for the ribs. Don't just say facet, say facet for the ribs. We have the demifacets on the body, and we have the facets on the transverse process. Again, the lateral view gives us a really good view of some of this. That demifacet is here on the body, but the key here is that we can see this very long, very sharp, inferiorly pointing spinous process, which is the key to the thoracic region. You can feel this one without even seeing it. If you close your eyes and feel it, you can feel that thoracic spinous process. Lumbar. Lumbar has these large kidney-shaped body. You know, it's this big, large body. We have the tapered, laterally pointing transverse process that kind of sticks out sideways. Laterally, we can see that this is rotated medially. The superior articular process is rotated medially, while the inferior articular process is laterally rotated. But again, it's the spinous process. This is blunt and wedge-shaped that will give you the biggest key to the lumbar. Here it is posteriorly. This is a better view of the rotated medial process, but you can definitely tell that very blunt spinous process and those thin tapered transverse processes. These are thin and tapered. L5 is the atypical lumbar. You don't have to be able to, it doesn't have a name. The key here is just that you have to know that the transverse process goes directly into the body. That's because it has to take the entire weight of the spinal column. Therefore, that makes it atypical.